say you flip a coin. Here's our coin. We've done this before. Abraham Lincoln, whoever it is. What is your probability when you flip a coin of getting a head? Lucas says 1/2, which he's right. Because probability comes from how many choices you have go on the bottom, head or tail. Heads takes up one of those choices, so it's 1/2. What about if I took a number cube and rolled it, and I asked you what's the probability of rolling a 7? Oops, sorry. Let's make it a real thing. Probability of rolling a 5. Okay, it's 1/6 because there are 6 different sides and only one of them is a 5. But if I asked you what the probability of doing both of those things in a row would be, probability of rolling a head and the probability of spinning a 5 or rolling a 5, what would that be? What's the probability of both of those things happening? Now before you answer that, one way that you can do this is you can do a little tree diagram kind of thing. In other words, the probability when you flip a coin, you can either get a head or a tail. Okay? And the probability of rolling a 5 or whatever, the different possibilities are, you could roll a 1, a 2, a 3, a 4, a 5, or a 6. I can make this little tree diagram to show all of my combinations. And I can get the same thing if I do a tail. A 1, a 2, a 3, a 4, a 5, a 6. I can get the 6 to go. So how many different combinations are there? If I were to list all these, I would have a head. I can get a head and a 1. I don't know why it's not working. A head and a 1. I can get a head and a 2. I could get a head and a 3. I could get a head and a 4. I can get a head and a 5. It's really slow today. And I can get a head and a 6. And then I got all of these tails. Tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. So how many different combinations are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 different possibilities. How many of those 12 possibilities are a head 5? Just 1. So the probability of doing both this and this is 1/12. Now, you really don't want to have to draw all of these things out. So there is a little rule when you want two things to happen. Does anybody know what that rule might be? Maybe you can see it by looking at what we have on the board there. It's called the multiplication rule of probability. I don't know if that gives you a hint. What is the multiplication rule of probability? Multiplication rule of probability. Nikki Kala is?
If you multiply the probability of it being a head and the probability of it being 5 together.
You just need to, when you have two different events, you multiply their probabilities together. Okay, when you have two different events, you multiply the probabilities together. You know, for example, if I asked you what the probability of drawing a jack out of a deck of cards and then putting it back and then drawing an ace out of a deck of cards. Probability of drawing a jack, probability of drawing an ace. Well, what's the probability of drawing a jack? Okay, 4 out of 52, which is the same thing as what? 1 out of 13. Just so you know. What's the probability of drawing an ace?
2 out of. Wait,
No, there's 4 aces. Still 4 out of, I'm sorry, this should be times. Still 4 out of 52, which is 1 out of 13. The probability that you will draw a jack and then an ace, you'd have to put the jack back, by the way, because that would change, would be 1 out of 169 times. That you would pull a jack and then an ace back out again. Okay, which isn't very, that would mean this. I could offer you $100. Well, if I had you pay me, you know, I could have you pay for, I'd say, hey, for $1, you want to draw and see if you can get a jack and then an ace, in which case I would pay you $100 if you did. I'm still going to win because the payout is less than the odds of the probability. Okay. For this to be completely fair, I should tell you I'm going to give you $169 if you actually do this. But instead, I'm going to give you $100 because I'm going to pocket the rest, like casinos do, and like the bingo do. If you really think that your odds of winning those things are good, they are not, because if you've ever driven by the casinos, and I don't think I've been to one in my life here, what do they look like, casinos?
Huge.
Pretty spiffy and nice, aren't they?
Yeah. Awesome.
Where do you think they get the money to build these nice buildings?
Cheap people love their money.
Yeah, all those people donate it when they go in there and play all these games. They say, here, take my money, build these nice things, I'll come in here and play on the thought that maybe, just maybe, I'm gonna, hit it big or do whatever. Yes, the redeeming thought, Lucas, is that some people do. Lucas, how many people do you know that have won the lottery? Any of them? I mean, most people know somebody.
And you only get half of the lottery.
Joey Joe.
Actually, no, you don't get that.
Jeremy's dad won a scratch one. How much was it worth, Jeremy?
They take 60%.
Oh, that's right.
Yes,
The $2 scratch one is always the good one. Let's look at a couple more examples here, just because. Maybe we should pull up the thing here. Let me stop this. Change, stop this.